if this car hits this car, I can predict what the speed of the cars will be in the future. When I mix this liquid and that liquid, I can predict that yellow precipitate. I can predict the future. We do it all the time in science, we predict the future. Oh, but those astrologers, when they say they don't believe them, just believe us. This has to be confusing. And it is, because most of the public, more public believes in astrology than in science. Because we never help them see why do we believe and when do we not believe. And the idea of falsifiability is a big part of this belief. So let's look. Why do we believe? Or maybe it's easier to look at this and say, when do we not believe? When do we not believe these things? When do we start raising a question and not believing? So, again, in active physics, we have Newton's second law and a rear-end collision. So we ask, does the content fit with other content? Yes, it does. It's forces in motion. That's good physics stuff. Does it fit with the big ideas of science? Yes, there are systems. And does it deal with expression? Yes, optimal prediction explanation. In fact, is the use of headrats also consistent not only with Newton's second law, but Newton's first law, because we value that consistency. And that brings us to the last of the questions, which is, why should I care? So, why should anybody care about any of these things? Now, when I say anybody, I mean kids that I deal with now in Boston, who are 14 years old in urban America. Tell me why they should care about mitochondria or the adipose nucleus. We know that motivated students have higher achievement. We know that they need relevance to their lives now. So we have these two answers, because students sometimes say, why are we learning this? And we have these two horrible answers. One is, this is chapter 14, you need it for chapter 15. And you know, if you give that answer, you think, I nailed that one, because they never ask you again. Because they're smart enough to know how you can answer the next one. But then sometimes we try to be creative and we say, oh, one day this will be useful for you. The big lie in American education. One day this will be useful to you. First of all, it's not about now, and not about their lives, but it's about something, and as I said, it's not even true. Tell me, except for the math science people around here, who has ever used that after high school? Ever. And in fact, I will go further than that. I will say if you're a math science person, you've never used it after high school. Well, sometimes when you're in a jam and you don't have any technology with you, you'll do it. But in fact, when I solve a lot of quadratic equations, what I do is I take out my TI-85 calculator, I plug in the coefficients A, B, and C, and it gives me the roots. I'm not taking square roots anymore. I actually remember how to take a square root. You give me a number like 10,423, I know how to take a square root by hand, without a machine. I never use that skill anymore. Nobody is using, just nobody's doing this anymore. And in fact, people have memorized it. We can have this mantra, x minus b plus or minus squared, b squared minus 4ac, all over 2a. Everybody in America knows that, but nobody used it. And in fact, if you try to get to the, how do we know this? If you say, so how do we even know that that gives the roots? Although somewhere in your math book it showed you. Somewhere in the math book it actually had this way of completing the square in order to find out this equation. Most people don't even know it's completing the square, and if you tell them it's completing the square, they still can't derive this equation, which is what the math is all about. Cosine 24. Really? After high school, there are 2 times you use cosine 24 if you don't go to science and math, which is 7% of our population. One is when you'll be happy when your son is in high school, when you have to teach him about cosine. You'll be glad to remember. But actually, when you teach cosine, you will see the kids perk up a little bit because they heard their parents arguing over who would cosine alone. And so they think, wait, I think this is finally something in math that's important. John Dewey, the great American philosopher of education, said, education is not a preparation for life. Education is life itself. Everything we teach, we have to find the relevance for the students in front of us. And that's probably the hardest of these 4 questions. If we want students to learn about science, we have to respect them and their age-appropriate perspective. So in science, we have ways of doing that. Physics of sports, chemistry of cooking, earth science of global warming, all of these kinds of things. So what I do is I put these questions in front of my room. I just put them in front. The 4 questions are in front of the room. And so I'm reminded of them, the students are, because I value them. But one day, I found I had this unintended consequence. I'm in the middle of, we're talking about something, we're learning something in science. And one of the students just raises her hand and points and says, at the sign says, why should I care? And I realized how powerful having that sign up there was. Because there is no way a child can ask that without being rude or impolite. But because it's there in front of the room, the student can point and say, why should I care? And I realized the student is saying, I'm not engaged, help me. Help me be engaged so I can do better. And I could not think of another way in which they could have asked that. I discuss them in class. I assign them as homework. I give them as test questions. And they're for all students, not just for honor students, not just an enhancement of the content for a select field. You know, we look at our goals as science teachers. What are our goals as science teachers? Higher student achievement, engage students, appreciation, dare I say, love of science or math in the world, critical thinking. 5 years later, I think we can all agree on the top 4. It's like, yes, yes, yes. I mean, if somebody has a problem with those, we can talk about that. But I think those are goals. But I have this other goal. 5 years later, what do you want students to remember? So if you're going to meet a student 5 years after you've had them in class, and you meet them somewhere and you say, so what do you remember about class? And I don't want to hear oh, it was a great class, you were wonderful, I like you, oh, we had fun. No. What do you remember about what you learned? What do you remember about chemistry or math or physics from that year? And it's scary because it's so disappointing to find out the answers that they have for these 5 years. So a couple of years ago, I was teaching a course to our honor students at the University of Massachusetts. So it's a course I do, Revolutions in Physics. So we have 15 weeks, we do a different revolution every week. And what I said to the students in the middle of one of the classes was, these are not science majors, they are criminal justice and sociology, political science majors, some others. But I asked them, so what do you remember about chemistry? They said, nothing. I said, oh, come on. How many took chemistry? They all had taken high school chemistry. I said, so what do you remember? I couldn't get anything. Nothing. I said, you have to remember, it was a year of your life. 45 minutes every day for a year. You remember nothing? And then somebody said, wait, I remember the mole. I said, great. What do you remember about the mole? Anyone? And I was, if one of them said, it's like a dozen, I would have felt great. But no, they said no. Oh, that's wait, I remember what I said. We had mole day. We made these stuffed animals or something, or made pictures. It was, some day in October or whatever. I said, oh. So, oh, it's coming up next week. And then I said, do you remember Avogadro's number? And they said, oh yes, we remember that. I said, what do you remember about Avogadro's number? Nothing. Until finally somebody said, wait, I do remember something, what's that? There's a 6 in it. Can you imagine a year of chemistry and what they remember is that Avogadro's number has a 6 in it? It's not even the most important number. So what do we want our students to remember in 5 years? And if you don't know the answer that's going to make your heart go pitter-patter when you meet that student in 5 years, if you don't know the answer to this question, what you want that student to say to you, they will never say it. You have to know what that answer is. What do we value? We value the big ideas of science, we value inquiry, we value science as a way of knowing. So here are the 4 questions. What does it mean? How do we know? Why do we do? Why should I care? On the other hand, the students have their 4 questions. What did you say? Should we write this down? Do we have to know this? Will this be on the test? This is our choice. Which 4 questions do we support? You don't need to sign this one's on the right. They know those. So let's put it into a larger context. Shabelson and Lee, in their studies of assessment, talk about, they use bigger words. Declarative knowledge, knowing that. I think it's what does it mean. Procedural knowledge, knowing how. How do we know? Systematic knowledge. Why do we believe? Knowing why. And strategic knowledge, knowing when and where to apply knowledge. Or why should we care? In the NAEP frameworks, 2009 to 2019, they talk about identity.